engineers, James Muridi here, doing what we do best, which is to make you a little bit more productive, to give you one act per day to improve your workflow efficiency, and of course, connect as a community of IE design engineers. And today I want us to look at something that is very important. I've been getting a little bit of more requests around the same, and it is key in road design, ensuring that your design adheres to the set design standards and guidelines, which also ensures that we are designing sustainable and safe infrastructure for the beautiful people who are going to use these infrastructures. So today I want us to focus on vertical alignment, which influences different aspects of an infrastructure of our own project. For example, when we talk of vertical alignment, we have the two main design elements. The first one is the straight grades, which is controlled by the gradient. And once you look at my screen here, we have a gradient here, for example, of 0.8. So the straight sections, what we call straight in horizontal alignment, here we are calling them straight grades, and it's controlled by the gradient. You have it here, right? The second thing, of course, is the vertical curves, where we have the crest and the sag curves. So this is a vertical crest curve right here, and you see it has its parameters right there. We go get to that. This is a sag curve. When you talk of these two elements, the straight grade determines, number one, or influences drainage characteristics of that specific area. That is during the design and operational stage. It also influences the construction cost, of course, and then the comfort of the road users. So one thing that you should note, and this is the rule of the thumb, is avoid short grades between two successive vertical sag curves, because it gives an illusion of an optical hump. But we're going to get to that later on. So what does the manual say about vertical design? Right, design of vertical curves. So let us look at the RDM, which is the geometric design for rural roads used in Kenya. And it is giving us a condition, especially when it comes to gradients. So we have the maximum gradient at this point should be for a design speed. Let's take an example of a design speed of 50 kilometers per hour. The maximum design speed for various topographical terrains are listed here. In this case, I want us to assume the worst case scenario of a mountainous terrain, and the maximum grade is 9%. One of the most ignored but important aspect is the minimum gradient, because these are the maximums. They are going to affect a vehicle speeds when they are moving uphill. But also, we need to consider the 0.5%, which is the minimum, and it influences drainage, especially at the grade section. So we have a 0.5, and we are going to take care of that right away. Another aspect, of course, is the length of your vertical curve, which should be 2 times, which should generally be not less than. So this is the minimum of 2 times the design speed. So in our case, it should be 50 by 200, right? The second aspect that I want us to look, and it's a major control for design of vertical curves, is the minimum sight distances. And in the minimum sight distances, I want to talk about two, very important. The first one is the design controls for stopping sight distance at crest and sag vertical curves. And for a design speed of 50, we have a design value of 7. And this is called the K value. When it comes to design, you're going to go to that slightly or in a bit. And then the second thing is the passing sight distance, which is right here. And for 50%, 50 kilometers per hour, then we need a K value of 138. So take note of those ones. So for passing sight distance, we have a K minimum value of 138 for passing side distance, and for stopping side distance, then our K value is 7. So how do you implement that in your design? So let's get there right away. And this is now our profile right here, and this is our finished road profile. And you can see most of the sections we have in our field section because this was more of a flat to rolling terrain. Okay. So how do we employ that? The first thing is you go to Home Ribbon Tool Space, activate the tool space, then go to Settings. So in Settings, this is where we set the profile parameters that we want our profile to, to adopt as the minimums, or rather to assign to our profile. The second thing is now reviewing what you have. You can see after the design, the K values have been given here, and all of this, we have the K values here. Then we have also the length of the vertical curves and also the points of vertical intersection. So let us go and create something that is called design checks. So in design checks, this is where you check and see the compliance of your design now to these profiles. Remember that these design checks can be set at any stage of the design, but also it's good to set them at the start so that it can guide you as you go. But also you can set them at the end so that you can check whether you're getting the principles right, in implementation. For an engineer, it's important for you to have the information in mind. So let's get into it right away, and you remember our parameters. So what we do is we go to menu in the tool space, we go to settings. Under settings, we go to profiles. Under profiles, you expand that icon and then you find design checks. And then the design checks, you can see the standard, for example. This is what is existing. This is what is preset from Autodesk, and you can see it has no information in it. So that means we need to create our own. So in this case, these are the ones that I had previously created to run this design, but I can get actually to delete them so that we can create our own with you right here. So the line is gone. That is for the straight grades, and then also for the curves, I can get to delete them. Yeah. So they're gone. Let us now create our own. You remember in the RDM, we had a minimum grade of 0.5% to ensure that there is no stagnation in our roads. So this one, we just click on line under design checks, line, create new. And in this case, we want to call this minimum grade. That case. Then go to expression where we have to write the code. In this case, it is important to know that you go to the function, to note that we have a rising and a falling. So in this case, we need to have an absolute value. And then after that, we now impute our element, which is tangent grade. Okay, that's our design element that we want to control. What parameters? It should be greater than or equal to 0.005 because that's a percentage. And then after that, you close it and then press OK. So the first one is set for the minimum grade. I'll be a little quick. So the next one, you repeat line, right click, you have add, create new, and then in this one, we want to call it the maximum grade, right? And then where do we get these values from? It's from the RDM table 5.41 for a design speed of 50. We have a maximum of 9% just to make sure. So in this case also, it will be an absolute function. And then after that, the design parameter is the tangent grade. And then in this case, it should be greater than or sorry, No, it should be less than or equal to, less than or equal to 0.009, close the bracket, and then press OK, right? So in that case, we are done with setting the parameters for our uh, grade sections. And then after that, we need to go to K values for our curves. And in the K value, it's called, the K parameter is the rate of vertical curvature, which is the length of the curve per percentage difference in intersection grade. So it's more of a ratio. In this case, we go to curves, right click, create new. Once you go to that, I want to have K value. Let me call this minimum K values. Okay. And in this case, we have two parameters that we want to do. This one should not be an absolute because it's a ratio. So you just don't go to that. Then in the function is the minimum K value for stopping sight distance. For me, it should be, minimum is 7. So the function should be greater than or equal to 7. That's how I want it to be. Close the bracket. Oh, okay. I don't need the bracket there. That's right. And then after that, I create another one, which is the minimum K for PSD, which is passing sight distance. Come again here. The function is minimum K value for passing sight distance, which should be greater than or equal to 138. If you're wondering where am I getting these figures from, I'm getting these figures from the Ashton Green Book, the Exhibit 3. You get the values for your K values, and in this case for a specific design speed of 50. That is what we're using as our example. So once you've set the parameters now, the work that is left is to implement these in your design. We just come to the profile now, the finished road level, because that's what we're checking. That's our design profile. Once you select on it, the contextual ribbon pops. And in this contextual ribbon, there you go to modify profile, and then there's profile properties. Click on that, and in this one, it gives us a wizard to set the design criteria, which is the third tab, which is design criteria. For you, if you had not set these, you find that the used criteria-based design is unchecked. So you check it. Once you check on that, then you have to select the criteria file that the software needs to follow. Remember, we are using the ASHTO because we don't have a country kit in Kenya. So in this case, we need to use the ASHTO Autodesk Civil 3D metric for 2011 roadway design standards, and then click on open. So you've assigned that. The same thing, this design file has the K minimum values. It has the K parameters. So when we give the condition, then it's going to reference from that. So you can see ASHTO 2011. And then as click on the icon with design check set. So you just select on these, and then you go to, you can create a new one. Once you create a new one, you will go to design checks. Under design checks, you select the first type is for the line. Once you select the icon for line, you will have the options. The options available is the maximum grade. You remember these are the ones that we were creating. So let's start with the maximum grade, select maximum grade, and then add. The next one is the minimum grade. You add it in the design check. And then the next one is for the curve. And then we have the minimum K values. This was for stopping sight distance. You add it. And then minimum K values for passing sight distance, and you add it in your design check set. After that, you get to apply and then press OK. And then in this case, you have it here. For example, if I go to edit, I can edit the current selection, go to information, and then say complete. Okay, no, Ashto 2011 design check. So yeah, that's the name. Is profile design check. After that, you can take ownership. My name is Mr. Workshop. So that's it. Apply, okay. Then you can see it has reflected there. Then apply and okay. So this means it has picked in your design, and immediately we get to apply. How do you know whether it has picked? Now, as you come to your profile, and for example, we can see our grade here is good, 0.8. It's not 0.5. It is above the minimum, and it's not to the maximum. So there is no, this one has not been flagged. And you come to this one, we can see an icon here, and it's telling us we have violated the minimum K value for passing site distance. You can see our site K value is 176. So let me see, we have violated it for this case. But remember, it's a general rule, it is impractical to design crest vertical curves to provide for passing site distance because of the high cost, especially where you have high crest cuts. So that will be expensive for you. So in this case, let us look at this one. Design check for minimum grade violated. So in the next video, we'll be looking at how now do we come to correct all of these figures. So stay tuned and watch the next video. So this is how you need to do your work, especially when it comes to ensuring that your design meets the minimum standards. Also note that this is not only in the design phase, you can also use this after even the design to carry out a compliance audit of your design. So thank you and see you in the next.